Okay, welcome Taylor Swift, welcome America, and welcome India to a review of Pythagorean theorem. It's our first lesson in Unit 7, which is all on right triangles, the entire unit. Probably the most important unit in geometry because it sets us up for the introduction to pre-calculus. So today we're going to do two problems here, okay? We're going to start with slide number 4. So we have a right triangle here where we know this is the hypotenuse because it's across from the right angle, and the other sides of the legs. Pythagorean theorem, as we learned, the area of the legs, this area, plus this area, the legs squared, I should say. Those two areas together equal the area of the hypotenuse squared. So what we do is we square this number, we find that area, we square this number, we find that area, we add them together, that gives us this area, and then we take the square root to find the length of the side, the missing side. And we do that algebraically. So it looks like this. And this is on our formula sheet. And I always put C first for a reason that you're going to learn in a few slides. C squared equals A squared plus B squared. C has to be the hypotenuse. So I'm going to put in X for C, and you can just leave it as C as you want, but I'll just put in X so we're not confused where the X is, where the side's coming from, equals A and B are interchangeable. It doesn't matter which leg you put first. 16 squared plus 30 squared. Now, this is where I see mistakes with the Pythagorean theorem, okay? So, order of operations. You need to square the numbers first before you can add them together. So we have to do 16 squared, and we've got a calculator. I can't use my calculator. Yeah. So what's 16 squared? It's 196, isn't it? No, what is it? No, that's 14 squared. 256. What's 30 squared? 900. Now, add those two numbers together. What do you get? Take the square root. That gives us the hypotenuse squared. And we need just the length of a hypotenuse. So what is that? Is that a perfect square? What do we get? Do we just get a number or do we get a decimal?
Here's 34.
34. Nice. That means it's a perfect square. Beautiful. That means the length of this missing side is 34. We just solved for the hypotenuse. Doesn't always work out perfectly like that. And the answer should be kept in simplest radical form whenever possible. So if we have a square root that has to be simplified, for example, let's say we end up with the square root of 20, okay? And we know that's not, when we do the square root of 20 in our calculator, we don't get, it's not a perfect square, we don't get a nice even number. So we would have to simplify the radical now that we know how to simplify radicals. So we would rewrite the 20 as the largest perfect square factor, which is 4, times 5. Take the 4 out, the square root of 4 is 2, and that would be 2 root 5, and that's just how you leave your answer rather than a decimal. All right. The next problem. Any questions? Okay. The next problem is when we have the other type of Pythagorean theorem example. Sometimes we are not asked to find C. We're asked to find the length of either A or B. So we're just going to follow the same exact formula. Does this look familiar? Do you guys remember this?
Yes.
Okay, so C squared equals A squared plus B squared. We're given C. 14 is across from the right angle. So the 14 goes in for the C. And I can put in X and 12 for whichever A and B. So I'm going to put X squared here and 12 squared here. So 14 squared is, it's 196, isn't it?
Yeah.
196 equals X squared plus 12 squared. We just reviewed our times tables. Should we do long division today? I was thinking we might do long division. Do you guys remember how to do long division? What's 196 minus 144? Notice I'm getting the numbers to the same side and I'm isolating the X squared and leaving it on one side. 52? Now, if I take the square root of that, I am not going to get a perfect square. All right, square root of 52 is not going to give us a whole number. So we are going to have to simplify that radical. Square root of 52. All right, so what two numbers, when I multiply, what's the largest perfect square that goes into 52 is the question. So then, and I've shown you how to do this, but it's been a bit. Here we go. 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 5 times 5 is 25. 36. Anything else that might go into 52? Probably not. Nothing bigger than that. Do any of these numbers go into 52 evenly? Try. Try it. Take the calculator, divide it by 4. Does 4 go into 52? What are my divisibility rules? 4 doesn't go into 52 evenly? This is why we need to do long division. 4 goes into 5 one time with 1 left over. 4 goes into 12 3 times. It goes in 13 times. You guys should be taking the calculator out and trying these. So 4 times 13 is 52. So when I simplify it, 52, I'm going to rewrite it as 4 times 13. I'm going to pull 4 out. Square root of 4 is 2, so it's 2 root 13. And that's how we write the answer. That's really the only difference between the last time I taught you Pythagorean theorem and this time is now we know how to simplify radicals. So we're writing the answers in simplified, simplest radical form. Questions? Okay, it's Friday.